Over 33,000 people die and roughly 2.4 million more are injured in motor vehicle crashes each year on our nation's roadways. Roughly half of those crashes occur at roadway curves or intersections. Excessive speed and driver inattention often create an environment where friction demand is higher than what can be countered with standard pavement surfaces, resulting in a loss of control. Vehicle friction demand is the level of friction needed to safely perform braking, steering, and acceleration maneuvers. High friction surface treatment, or HFST, addresses this problem by providing enhanced traction. When applied as a spot treatment at high-risk areas, HFST significantly reduces crashes, ultimately saving lives and avoiding injuries. High-friction surfacing serves as an excellent speed crash reduction countermeasure. Unlike reconstruction, HFST can be installed immediately on well-maintained pavement surfaces. It does not require years of delays for design, right-of-way acquisition, permitting, and environmental processes, or result in long construction-related corridor impacts. Most installations are completed in just a few hours. These low-cost location-specific treatments dramatically reduce risk factors, providing a cost-effective solution. HFST utilizes a liquid polymer resin binder onto which calcined bauxite aggregate is placed or sprayed. Once applied, surface friction is significantly enhanced when compared to traditional pavement treatments. As pavement friction increases, motorists are provided additional time to adjust speed back within safe parameters. HFST provides this enhanced safety in a manner usually obtained only through expensive and disruptive reconstruction designed at reducing friction demand. HFST is a proven safety countermeasure. Utilized since the early 1970s in Europe, Mexico, South America, and Asia, this technology is now being aggressively applied in the United States, resulting in dramatic crash reductions. More importantly, speed-related risk factors are reduced without depending on changes in driver behavior. In summary, HFST is a smart addition to any state or agency's speed countermeasure toolbox. It is an especially cost-effective method to address locations with high friction demand when compared with construction-related treatments. When considering HFST, site selection is the first step. Is there a history of crashes at the site, or does the site have similar characteristics to sites with known crash histories? Horizontal curves and intersections are sites where friction demand issues often arise. The second aspect of the site selection has to do with the current pavement condition. To evaluate current surface properties, friction testing may be conducted at the site. The friction test should be redone after the site has been treated with HFST to compare results. Application of HFST can more than double or triple surface friction. The condition of the pavement also must be evaluated. Cracking or other structural problems must be addressed prior to installation. Many HFST failed installations are a result of materials being installed on pavements in poor condition. Site selection and evaluation is key to a successful installation of HFST. Once a determination has been made that a location is a good candidate for HFST, decisions need to be made regarding the length of installation and how to prepare the surface. For example, once the cause of crashes has been determined, the next step is to physically define the crash zone. This means defining the area of the road that does not provide high enough friction for the conditions. Where does the motorist lose traction and the crash begin? Where does the crash zone end? Clearly defining the crash zone is critical to mitigating the risks associated with that specific curve or intersection. The next key component is to determine how far the HFST should extend beyond the crash zone. The ideal installation will extend beyond the crash zone in each direction. However, each site is different, and field evaluation can provide much clearer indications as to the limits of HFST. As a general rule of thumb for curves, the treatment should be applied between the points where the curve begins and ends, or the points of tangency. As discussed previously, the condition and type of surface is key. Some pavement types, for example, will need additional binder or even a second layer to ensure proper adhesion. Once the surface has been inspected, it is time to delineate the entire HFST surface area of the location in question. This designated area will determine how much material is required and how long the installation will take. It is at this point that consideration should be given to whether paved shoulders should also be treated. Lastly, it is important to identify existing pavement markings that can and should be retained. Raised and paved markers can be taped off and protected. Developing a thorough quality control and quality assurance plan is helpful in ensuring an effective installation of HFST. A site inspection of a potential project is the cornerstone of this planning process. The more detailed the inspection, the more accurate the plan, and the more successful the installation will be. Installation begins with proper preparation of the pavement surface to ensure an effective bond. Pavement markings in good condition should be retained by covering them with tape. Utilities and drainage structures within the treatment location should be protected as well. Taping the edges of the treatment area provide for a more even application. Painter's tape can also be used to prevent adhesion of reflective beads to the tape. Surface preparation begins with cleaning the pavement surface to remove oils, grease, and other matter. Thermoplastic pavement markings within installation sections need to be ground off the surface, or the HFST will not properly adhere. While there are many techniques for cleaning asphalt pavement surfaces, it is important to remember that insufficient cleaning and drying may result in delamination of the binder from the pavement surface. Asphalt pavement surfaces may be prepared using a mechanical sweeper and high-pressure air wash. New asphalt requires a minimum period of 30 days to cure prior to the installation of HFST. Concrete pavement must be cleaned by shot blasting, followed by vacuum sweeping or air washing of the surface to remove all loose dust and debris. Improper site preparation and installation of HFST on poor pavement surfaces are the two most common causes of delamination. The primary components of HFST are a liquid polymer resin-based product placed on the pavement surface into which an aggregate is embedded. HFST is different from other pavement surface treatments in that it is primarily designed to increase safety through enhanced pavement friction. Proper binder preparation is important, and thoroughly mixing the material is critical. Always consult the manufacturer for recommended application procedures. Materials improperly mixed will not cure and properly adhere to the surface and will need to be removed. There are various mixes and methods for installing HFST, including mechanical or manual application. This applies to both mixing the polymer resin and applying or spraying the aggregate. All methods are acceptable if performed properly and in adherence with manufacturer recommendations and construction specifications. The aggregate used in HFST is calcined bauxite. Calcined bauxite is an aluminum ore which, when heated to a high temperature, increases in physical hardness and stability. An 87% aluminum oxide content is typical in approved calcined bauxite. It must be clean and uniform in size for best results. A high percentage of dirt or dust in the aggregate will reduce the effectiveness of the HFST resin in bonding the aggregate particles to the pavement surface. Bauxite is used primarily because it resists polishing, which allows it to retain its friction values and properties even after years of wear. It is also available in different shades. Other aggregates will be considered in the future as the technology becomes more mature. The binders specified may vary depending upon pavement surface type and condition. The typical binder is a multi-component polymer resin. A good specification will always address the mechanical properties of the resin binder, along with limitations such as storage, mixing, and temperature restrictions. Weather and temperature are critical elements in proper installation of HFST. Most binder systems discourage the installation of HFST in temperatures lower than 50 degrees. The ideal temperature range for installation is 60 to 95 degrees Fahrenheit. Temperatures outside this range may affect working time for installing the material, curing time, development of ultimate strength, and proper embedment of the aggregate. Some polymer resin binders are designed to be installed in cooler temperatures. All surfaces receiving HFST must be thoroughly dry. Do not apply polymer resin binders on a wet surface. This could compromise the tensile bond of the HFST or could contribute to an early loss of aggregate from the surface of the system. In summary, surface preparation, surface temperature, binding mixing, and proper application techniques must be in conformance with manufacturer's specifications. There are three main methods for installing HFST. Fully automated, meaning machine mixed and machine applied. Partially automated, with a machine mix and manual application. And manual, with hand mixing and hand application. Each of the methods has advantages and disadvantages relating to speed of installation and ease of use. It is best to use the method that most appropriately suits your location and budget. HFST can be applied by machine at a similar speed to other paving surface treatments, or can be applied manually on small projects by local workforces. Typically, HFST projects are completed within a few hours and the materials cure quickly. The installation often can be completed with minimal impact on local traffic. Regardless of installation method, it is critical that close attention is paid to the following steps. First, the binder materials are mixed in the correct proportion prior to installation. Follow the manufacturer's specifications for the specific binder used. Second, the binder film is applied using the correct thickness to ensure successful adhesion of the binder to the pavement surface and the aggregate to the binder. Third, there is adequate aggregate coverage once the binder is laid. Always check the work in progress to ensure that your quality control, quality assurance plans are being implemented in accordance with the engineering plan and the material manufacturer's specifications. Once the HFST is installed, it is important to sweep or vacuum any excess bauxite for disposal or reuse in another project. Reclaimed bauxite should be inspected for foreign matter. If necessary, the aggregate should be sieved to remove foreign matter and debris before it is reused. Aggregate should also be checked for uniformity. The aggregate should comply with the gradation requirement in the specification and should be monitored to ensure segregation of larger and smaller aggregate particles. A critical quality control step for agencies is to inspect the installation. Some inspections will occur during the project, and some will follow completion of the installation. During the installation process, it is important to inspect for areas where the binder and bauxite aggregate are missing. If found during installation, the areas can be filled to ensure uniform coverage. It is also critical to inspect for areas where the binder has not cured properly and is soft. These areas may need to be repaired or removed and reapplied. Consistency is key. Inspect for continuity in application to ensure a uniform surface. Once the installation is complete, inspect for excessive shedding of aggregate. Covered pavement markings and utilities should be uncovered. If any road markings need to be replaced, this should be completed prior to reopening to traffic. If a section has failed, it will need to be removed by grinding or milling. The final quality control test is to perform friction tests. The first test should be performed within 30 days of installation using a locked wheel skid trailer or a dynamic friction tester. A proper installation should result in skid trailer friction numbers in excess of 65, although it is not uncommon to see friction values in the 80s or 90s. Friction testing should be conducted at 6-month intervals and on an annual basis thereafter to ensure that friction values are maintained. Each year, more than 28% of all highway fatalities occur at or near horizontal curves. Increasing surface friction at these critical locations saves lives and reduces crashes. Crash data collected to date demonstrates significant crash reduction benefits with the installation of high-friction surfaces in the United States and around the world. In Milwaukee, for example, HFST was installed on a ramp that had been the site of 87 crashes in just 1 year. In October of 2011, HFST was installed. Since that time, only 2 crashes have occurred. In Oldham County, Kentucky, there was a horizontal curve that recorded 53 wet and 3 dry crashes over a 3-year period. After treatment, those statistics dropped to 5 wet and 0 dry crashes over the next 3 years. There are similar stories found all around the country. High-friction surfacing is valuable as a new speed crash reduction tool. When compared to expensive and time-consuming geometric fixes, high-friction surfacing is a low-cost countermeasure, helping to reduce roadway departure crashes and to save lives. As you consider the use of these materials, we ask that you apply the principles demonstrated in this video to ensure effective installation of this life-saving technology. The following information can help you learn more about high-friction surface treatment installation and pavement friction management.